All right, guys, welcome back. Now, we just did number 1 of the week 3 assignment. Let's do number 2 and 3, and then I'll mention number 4. And number 4, I'll let you guys do independently. I think you'll be able to do it by then. Okay, so let's look at number 2. It says, use the variable name's position and effectiveness to conduct an independent sample t-test to see if there's a significant difference of effectiveness scores between the managers and the staff. Now notice that they're coded 1 and 2. Let me explain that. Let me minimize this, go into our data set. Over here where it says position, we've coded the positions 1, 2, and 3. 1 being the managers, 2 being the staff, and 3 being the executives. Okay, and here's my variable here of effectiveness. All right, so again, an assumption, is this continuous data? We're going to assume that it is. That effectiveness is maybe on a scale of 1 to 15 or 1 to 20, and they can be subdivided equally, therefore it's continuous. So we're going to make that assumption here. Okay, so let's go ahead and do it. We're going to go to Analyze. Okay, again with the compare means. This time we're going to go to independent sample t-test. Excuse me. Okay, so we need to have the two things that we're comparing, okay? The test variable is going to be effectiveness. Now, that's going to be the one of the variables. Now, the grouping variable, we're going to put in the positions. We're going to put that down here. Now, with the positions, that's all of them, 1, 2, and 3, right? Manager, staff, executive. So I'm going to be more specific. I want to compare 2 groups. And this test is set up for comparing only 2 groups. So where I'm pointing defined groups, that's asking me what is going to be group 1 and which one's going to be group 2. See, it's asking me. So for group 1, the 2 things that I'm comparing here are managers and staff. Managers and staff are coded 1 and 2 respectively. Okay, so group 1 will be my managers, which is 1. Group 2 is my staff, which is 2. And that's it. You go to continue. Okay. And there you have your results. Now I want you to type up what this means. Now again, with the assumptions, we're going to assume that these are all continuous data, that they've been sampled randomly, and that because we did an independent t-test, they are independent from one another. So the question is here, is it indeed independent? Because we're talking about managers and staff. You can make the argument that managers and staff, they work under the same roof, they're working for the same company, they know each other, they're not so independent in terms of effectiveness. They know what the criteria is, they know that they're working with each other, they see each other working. It's not so independent. So you can say, you know what, it doesn't meet the definition here, so we can do another t-test. But for now, we're going to assume that even though they're managers and the staff, that they maybe from a different branch, and they don't know each other, and they don't have too much in common. So the 2 samples, let's say, that are independent. That's why we chose the independent tool here, the independent t-test. So let's look at this. So homogeneity of variance. Let's look over here to this here. Let's look at significance. Equal variance assumed. If you're assuming that the variance between the scores of one category is kind of the same, and you need that to be the same in order to continue with the rest of your analysis, that number has to be more than 0.05. Okay, for this purpose, more than 0.05 means that the differences were within the acceptable range. Okay, for us to assume that the variances are equal. So this number has to be more than 0.05, and indeed it is. So let's move over to this, the significance two-tailed. And again, we're comparing the difference between managers and staff. Is it significantly different? Is it more or less than 0.05? Before we attempt to answer that, let's look up here. The group statistics. If you look at managers, the mean of the managers is 11.64 on a scale of effectiveness. If you look at staff, they score 8.73 on a scale of effectiveness. Ostensibly, just looking at it, you say the managers are more effective. But in statistics, we don't want to just look at the numbers and say one is bigger than the other, therefore one is better than the other. The whole point of doing a t-test and the other tests that we'll be doing later on is to calculate significance. Because ostensibly it could be different, but statistically, if it isn't statistically different, you can say that that difference was caused by just, luck, by random chance, rather than be caused by something. So you want to be able to say that managers are indeed more effective than staff because of something that causes them to be more effective, like some intervention or some training or maybe the school that they went to. If it's not statistically different, then what we're suggesting is that if you continue doing this test, maybe the next time the staff will be higher, and it'll vary. So it isn't really caused to maybe the superior training that the managers have. Every time you do a sample, these numbers might flip-flop. Okay, so we want to look for a statistical difference, not just an ostensive difference. So look at this. If our equivariance is assumed, and it is, continue on that row and look at this number. If it's less than 0.05, it's significant. So ask yourself, is 0.048 less than 0.05? Yes, it is. So the difference between the effectiveness scores of managers and staff is significant. That means that that difference was not caused by just random chance alone. There's some factor that makes the effectiveness of managers superior to staff. What it is, well, it depends on how you set up the study and whether or not you're going to be able to identify that, okay? All right, so that's that. Okay, let me get out of here and let me go on to the very next assignment, and we'll keep it in the same video. So the next assignment says, okay, now compare the managers and the executives. You do the exact same thing. Let's go to Analyze, Compare Means, Independent Sample, and let me start all over. All right, just to review. So again, we're putting effectiveness up here, okay, as test variable. Grouping variable, we're putting positions. Now it's going to ask you, well, what two groups do you want me to compare? Well, the number one group is going to still be managers, which is 1. And then you want me to compare it to the next group, and this time it's going to be executives, and those are 3. Hit continue, hit OK. Okay, again. Look at the difference. Ostensibly, the managers are doing better than the executives. Okay. Now, was that just by luck, random chance alone, or are the managers tapping into something that we need to know about? What makes them better? So if it isn't done by just random chance, they're really, maybe they all graduated from a really good university or something. I don't know. And in the executives, not so much. You want to know that this isn't just chance alone. So you look at statistical significance. Okay, so equivariance. Is this more than 0.05? It is. Okay, so we can assume that the variance is good, is within what we want. Then we look at the significance of the two-tail on the bell curve. Is it more than 0.05? If it's more than 0.05, it is not significant. Okay? It needs to be less than 0.05 for the difference between the two to be significant. So ask yourself now, is 0.123 less than 0.05? No, it is not. So we have to say that the difference between managers and executives, even though ostensibly there seems to be a difference, is not statistically different. That means statistically it's kind of a tie. Okay? And it might be because of chance alone. The day you took the data in, the day you interviewed them, the the day you collected the data and interpreted it. So this isn't significant. So even though you say, yeah, 11 is more than 9, no. Statistically, that's not enough of a difference for you to say that managers are outperforming executives. That could be just by luck. So we keep it that way. So for this one, you can say the difference is not statistically different. Okay, so let me get out of here. Let me bring up the assignment for the last one. Okay, the last one I want you to do on your own. So this is called a paired test, paired t-test, and paired is different than independent t-test because here you need to you're making the assumption that they have a lot in common. They're not completely independent. They're in the same classroom. They're maybe the same teacher. They're from the same family. They know each other. They work with each other. So the data comes from the same pool, so to speak. So you're going to go to the same place that we went to pull down the independent t-test, only now you're going to go for where it says paired t-test. And you're going to do two comparisons. You're going to compare April and June, and then you're going to compare September and November. Okay, so I won't run the test, but I'll just start it. So the rest of it you can do independently. Okay, so here's April, June, and so on. So you're going to analyze. You go to compare means, and here's paired sample. And there you go. Okay. So let's try to do this on your own, and give it your best shot. And then if you have any questions on this part or any other of the other parts, let me know.